Welcome back students to the another lecture of chapter 8 Motion of Physics. In this lecture we are going to deal with the numericals related to speed and velocity. First of all, let us recall what we studied in the last lecture. Speed. What is speed? Speed is the distance traveled by the body in unit time. Its SI unit is meter per second. It is a scalar quantity. Its formula is speed is equal to distance upon time, that is V is equal to S upon T. And the formula for average speed is total distance upon total time. Now velocity. What is velocity? It is displacement of the body in unit time. It is a vector quantity. Its SI unit is meter per second. Formula for velocity is displacement upon time. And the formula for average velocity is initial velocity plus final velocity divided by 2. And what is velocity? Velocity is speed with direction. If it is not having direction, it is speed, and if it is having direction, it is velocity. So students, let us start with the numerical. The odometer of a car reads 2000 km at the start of the trip and 2400 km at the end of the trip. If trip took 8 hours, calculate average speed of the car in km per hour and meter per second. First of all, odometer. What is odometer? We have studied. Odometer is a device in the vehicle which measures the distance traveled. So here odometer is reading 2000 km at the start of the trip and 2400 km at the end of the trip. So total distance traveled by the car is S. We know that distance traveled by the car is denoted by S. S is equal to 2400 km minus 2000 km, that is equal to 400 km, and the time is 8 hours. So we'll apply the formula of the speed. Speed is equal to distance upon time, that is 400 by 8, that is 50 km per hour, which is the speed we got in kilometer per hour. Now we have to convert that speed into meter per second. 1 kilometer is equal to 1000 meter and 1 hour is equal to 3600 second. So 50 kilometer per hour can be converted in terms of meter per second by 50 into 1000 upon 3600, that is equal to 13.9 meter per second. You might have found this conversion a bit complicated, so now let us see how simply we can convert kilometer per hour into meter per second. Now students, you know 1 kilometer is equal to 1000 meter and 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So 1 hour is equal to 3600 second. Now kilometer per hour can be written as 1 kilometer upon 1 hour. 1 kilometer can be written as 1000 meter and 1 hour can be written as 3600 second. So we'll get 10 by 16 meter per second, that is equal to 5 by 18 meter per second. So if you want to convert kilometer per hour into meter per second, just you have to apply the formula 1 kilometer per hour is equal to 5 by 18 meter per second. Suppose if you want to convert 36 kilometer per hour into meter per second, just do 36 into 5 by 18, that is equal to 10 meter per second. So students, now let us see next question. Usha swims in a 90 meter long pool. She covers 180 meter in 1 minute by swimming from one end to other and back along the same straight path. Find average speed and average velocity of Usha. Here she is going from one end to another end and again coming back to same end. So total distance covered by her is 180 meter. And the time taken is 1 minute. But since she is coming back to same place from where she has started, her displacement is 0. Because you know that displacement is distance between initial position and final position. Here initial position and final position are same, so her displacement is 0 and distance traveled by her is 180 meter. First of all, we will calculate average speed. You know what is the formula for average speed, right? Average speed is equal to total distance upon total time. Now what is the total distance? 180 meter. And what is total time? 1 minute. Here we have to convert minute into second. So 1 minute is equal to 60 seconds. So it will be 180 by 60, that is equal to 3 meter per second. So her average speed is 3 meter per second. Now let us calculate her average velocity. The formula for average velocity is displacement upon time taken. And we know that her displacement is 0 meter. So it will be 0 by 60, that is equal to 0 meter per second. So her average velocity is 0 meter per second. Next question. A train takes 2 hours to reach Vadodara from Ahmedabad. The same train takes 3 hours while coming back to Ahmedabad. Distance between Ahmedabad and Vadodara is 100 km. Calculate the average speed and average velocity of the train. Here train is going from Ahmedabad to Vadodara and coming back. So total distance travelled by the train is 100 km plus 100 km, that is 200 km. And the displacement of the train is 0 since it is coming back to the same place from where it has started. And the total time taken for the journey is 2 hours plus 3 hours. 2 hours for going and 3 hours for coming back. So total 5 hours. So students, now it is very easy. You know how to calculate average speed. It is total distance travelled upon time taken. Total distance is 200 and total time is 5. So 200 by 5, that is equal to 400 km per hour. And formula for average velocity is displacement upon time. Displacement is 0. So average velocity of the train is 0 meter per second. Let us see another question. During an experiment, a signal from the spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at a speed of light, that is 3 into 10 raised to 8 meter per second. So first of all, here what is given to us, students? Speed. Speed is denoted by V. So V is equal to 3 into 10 raised to 8 meter per second. Or you can denote it by U also. And time is 5 minutes. So we need to convert it first of all into second, that is 5 into 60, that is equal to 300 second, that is your T. Now what is the formula for speed? Speed is equal to distance upon time, that is V is equal to S upon T. Here S and T are given, so we'll make distance as subject. So distance is equal to speed into time, that is 3 into 10 raised to 8 into 300. Now 300 can be written as 3 into 10 raised to 2. You are knowing, you have studied in lower classes. So it can be written as 3 into 10 raised to 8 into 3 into 10 raised to 2. 3 into 3 is 9 and 10 raised to 8 into 10 raised to 2 is 10 raised to 10. According to the law, a raised to m into a raised to n is equal to a raised to m plus n. You have already studied in Maths chapter 1. So the distance is 9 into 10 raised to 8 meter. Now students, let us see some questions of your exercise. Question number 2. Joseph jogs from one end A to other end B of a straight 300 meter road in 2 minutes 30 seconds and then returns around and jogs 100 meter back to point C in another 1 minute. What are the Joseph's average speeds and velocities in jogging? First one from A to B and second one from A to C. So, first of all, see the diagram. Here, the distance from A to B, that is, first of all, he is going from A to B and that distance is 300 meter. And then he is going from B to C, that distance is 100 meter. Time taken for A to B is 2 minutes 30 seconds and time taken for B to C is 1 minute. We are asked to calculate average speeds and average velocities from A to B and A to C. First of all, we will find from A to B. Time for A to B is 2 minutes 30 seconds. So students, now you know what you have to do. You have to convert it into seconds. How you will convert? 2 into 60 plus 30, that is equal to 150 seconds. That is the time for A to B. So, average speed from A to B is total distance upon total time. Total distance is 300 and total time is 150. That is equal to 2 meter per second. And average velocity is displacement upon time. He was moving in a straight path. So, distance and displacement are same. That is from A to B. Distance and displacement are same. So, 300 by 150, that is equal to 2 meter per second. Now we will calculate for A to C in the same way. Now when he is moving from A to C, total distance covered by him is A to B and then B to C. A to B is 300 and B to C is 100. So total distance is 400. And total time taken is for A to B 150 seconds and for B to C it was 1 minute, and we know that 1 minute is equal to 60 seconds. So 150 plus 60, that is equal to 210 seconds. So average speed is equal to total distance upon total time, that is 400 by 210, that is 1.9 meter per second. And average velocity is equal to displacement upon time, and total displacement is from A to C. Now A to B was 300 and B to C was 100. So A to C will be 300 minus 100, that is equal to 200 meter. So displacement is 200 divided by 210, that is 0.95 meter per second. Question number 3. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed of Abdul's trip? So here he is going to school, and during that his average speed was 20 km per hour. Then he is coming back from school from the same path. So distance is same in both the cases, but there was less traffic, so his average speed was 30 km per hour, and we are asked to find the average speed of his whole trip. Here how much distance is there, that is also not given. How much time he has taken, that is also not given. Just average speed in both the cases are given. So let us suppose that distance of Abdul's home to school is x kilometer. Now while driving to school, first of all we will use the formula average speed is equal to distance upon time. What is the average speed given to us? 20 km per hour. What we supposed? Distance as x, and will take time as t1. Call it as equation number 1. Now on his return trip, average speed is equal to distance upon time. What was the average speed? 30 km per hour. Distance is same, so x, and time will take as t2. Call it as equation number 2. Now average speed is total distance of the journey and total time of the journey. So total distance is x plus x, that is from home to school and school to home, that is 2x, and total time will be time for first journey t1 plus time for second journey t2. From equation 1 and 2 will get t1 and t2 as x by 20 and x by 30. So total time t will be x by 20 plus x by 30. LCM of 20 and 30 is 60. So on solving we'll get 3x plus 2x by 60, that is equal to 5x by 60. Now average speed is equal to total distance upon total time, that is equal to 2x upon 5x by 60. That is equal to 2x into 60 by 5x, that is equal to 24 km per hour. So average speed of his journey is 24 km per hour. So students, these were the numericals related to speed and velocity. Practice them as many times as you can so that you will get thorough with them properly. We'll continue with the next topics in the next lecture.